This method can create LSMO nanoparticles uniformly on a STO single crystal substrate. Also, the GBCO film can be obtained through the same method in the same vacuum chamber. The main advantage of this technology is that LSMO nanoparticles with uniform size and high-quality superconducting GBCO film can be deposited in the same vacuum chamber. This method can provide insight into film deposition area, nanoparticle growth area, etc. It can also be applied to metal film deposition, metal nanoparticle deposition, etc. This method will allow researchers to become familiar with vacuum equipment and learn more about film growth technology.
First, sequentially clean strontium titanium oxide single crystal substrates in isopropanol and deionized water for 10 minutes each at room temperature in an ultrasonic bath. Then dry the substrates with nitrogen. This promotes uniform covering of the substrate and good film adherence. Mount the 001-oriented STO substrates in substrate holders with silver powder conductive glue. Load the holders into a vacuum chamber. Mount an LSMO target in a magnetron injection gun, and then reassemble the gun. Test the resistance with an ohmmeter to avoid a short circuit between the magnetron and the surrounding shield. Then close the vacuum chamber and pump down. Once the vacuum is lower than 1 × 10⁻⁴ pascals, heat the substrate to 850 degrees Celsius using a heating rate of 15 degrees Celsius.